हेलो, व्हाट्सअप कैसे हैं आप? हाउ यू डूइंग? मेरी आवाज साफ आ रही है? आर यू एबल टू सी मी? वेल, प्रॉब्ली नॉट. आवाज आ रही है, राइट? यू शुड be able to hear me. Hey Shubhi, how you doing? You came a little bit early. You should have seen me right about now. What's up? I'll just move on to the other side quickly. ये नीट वाला का सेटअप है. Let's go to the JEE वाला सेटअप. Well, नीट और JEE मतलब चैनल का एक्चुअली कंटेंट तो सेम है, थ्योरी सेम है, and you know that I do question solving sessions अलग अलग से. So we're going to do first law of thermodynamics आज. Such a beautiful Tuesday. Let's get started right away. You guys can hear me and see me, right? That's all right. That's all right. What's up, Archita? How you doing? Oh yeah, I should probably ping on Discord. I forgot about that. We'll do it. We'll do all of that and more. What's up, Joel? Good to see you. So, what is first law of thermodynamics all about? Dekho, I'll be honest with you. It's a little abstract, but we'll have fun with it. We always do. Quickly, NCRT खोल के देख लेते हैं. What is NCRT talking about? One moment, please. Brave? No, not Brave. Edge. We're going to go to Edge to look at NCRT. There you go. All right. This is what we're going to do today, right? मैं थोड़ा बहुत आपको आइडिया ऑलरेडी दे चुका हूँ. And this is what we ended the last session with. This idea. We'll just expand on this. Heat क्या होता है? Work क्या होता है? And then we'll say कि okay, well, what are different types of heat and work? They are both path functions, but उसको आप add करो तो बन जाता है state function, which is delta U. We'll do a little bit of question on state क्या होता है, path क्या होता है, सब करेंगे. And then we'll try and understand reversible और irreversible में क्या फर्क होता है. This is probably the most important part of this session. ये दोनों ग्राफ को समझना, ठीक है? We'll talk about this. A lot of people don't understand it. Again, a lot of teachers don't understand it. Who's have taken interview, जिनका मैं interview ले चुका हूँ, but you will definitely understand it by the end of this session. उसके बाद we'll do this reversible process कैसे calculate किया जाए, a little bit of calculus. We'll most likely end the session by then. If there's time, we'll also introduce enthalpy. That's the plan. That's the plan for today. What's up? How much time? Hi Ridhima. Hi Kunal. मिला क्या? अभी मिला. गुड पूजा. नमस्ते शुभी जी. राम प्रणाम. कुणाल. ऑलराइट, लेट्स गो. मेरी बुक में आधा प्रिंट किया. ओके, दैट्स नाइस, आई गेस. यू गाइस हैव वेरी यूनिक. एनीवे, हियर्स द फर्स्ट क्वेश्चन. लास्ट सेशन से रिलेटेड है. इस एग्जाम्पल्स में से कौन से एक्सटेंसिव एंड इंटेंसिव प्रॉपर्टीज हैं रिस्पेक्टिवली? एक्सटेंसिव कौन सा है, इंटेंसिव कौन सा है? या प्लीज लेट मी नो. अगर, and I've taught you this, okay, don't tell me, oh my god, what is enthalpy, what is entropy? If you paid attention to one slide, एक slide थी last class में, इसमें मैंने ये बताया था आपको. So if you don't know what these things are, maybe just maybe you know the answer to this. If you don't worry about it, I'll help you with it. B, Archita says B. एक चाहिए एक्सटेंसिव, दूसरा चाहिए इंटेंसिव. एक एक्सटेंसिव, दूसरा इंटेंसिव. Actually, no, this may be a little bit hard for you, to be honest. Now I think about it. No, actually, no, it's not. It's doable. I seriously feel it's doable. Try karo. I'll give you like 30 seconds. Try it out. I'm taking the 30 seconds basically to ping on my Discord server. Hey, the session has started. Thermo shuru ho gaya. All right. And I'm slow at typing. And we're done. Okay. सब लोग बोल रहे हैं C, D, B. Okay. I got a couple of takers. I see Ram. I see Kunal. I see Gufti. Welcome, Gufti. Also saying C. Kunal Fitz is saying C. Ridhima saying not A. All right. Archita saying C as well. All right. So a lot of people saying C. Varis going with D. Ridhima also going with C. It must be C. Okay. So maybe I'm not specifically taught you, bhai, entropy kya bala hai, what is enthalpy, but okay, we may not know that. But you can solve this just from temperature. Intensive सिर्फ temperature है. You may not know that, but एक ही option है, single correct है. That's why I said you can solve this question what I've taught you so far. Intensive मतलब एक point पे intensity होनी चाहिए. You should be able to say what is the temperature here? What is the temperature? You can measure it. भाई मैंने example दिया ना, thermometer लगा के एक point पे measure करते हो. It's intensive. These are extensive properties that depend on mass of stuff, and also it doesn't make sense to point out entropy of this point. Take a bulb, थोड़ा सामान लेके लो, and that's what they do this. Next question. In thermodynamics, a process is called reversible when system and surroundings change to each other. There is no boundary between system and surrounding. The surrounding is always in equilibrium with system. None of the above. Third वाला थोड़ा elegant लग रहा है. ये तो दूसरा वाला थोड़ा अतरंगी लग रहा है. Boundary ही हटा दी. That has no meaning. If you don't have a boundary, then you're not defining a system or a surrounding. If you're not defining anything, then what are you even doing, right? So this is a random option. Okay, system and surrounding change also a weird option. I think the only one that makes sense. This is an easy one. ये तो C होना चाहिए. Yeah. What's up? Pooja, all right. Sachin, welcome. All right, everybody figure it out. Swati, I feel it should be C. Archita, yeah. Most of the other people have figured it out. Okay, rhythm eyes on C. Kunal, क्या कर रहा है यार? ऐसा नहीं चलेगा Kunal. I will time you out if you do time pass like this. You have to take this seriously, boss, and everybody else here as well. Ram, thank you for giving me the answer. Okay, C is the right answer. Good job on this, right? सिस्टम और सराउंडिंग आर इक्विलिब्रियम, मतलब बहुत थोड़ा सा फर्क है और उस फर्क को हम लोग नेगेट कर सकते हैं बाय पुशिंग इट इन ईदर डायरेक्शन। वो एग्जांपल का सैंड का था ना, सैंड हम लोग धीरे 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 डालते रहते हैं तो उसके ऊपर प्रेशर धीरे 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 बढ़ता रहता है। या फिर अगर सैंड निकालो धीरे 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 वैक्यूम से, एक मिनट, सैंड से प्रेशर कैसे बदलेगा? नोबडी आस्क्ड मी दिस क्वेश्चन, सो आई डिडंट एड्रेस इट, बट वी विल एड्रेस इट टुडे। सैंड से प्रेशर कैसे आया? व्हाट इज प्रेशर? प्रेशर इज फोर्स बाय एरिया, राइट? फोर्स कहां से आया? mg। हाँ देखो, मास तो होता है, सैंड का मास होता है, यू कीपिंग इंक्रीजिंग द मास, एरिया द सेम, ग्रेविटी तो है ही, तो if you increase the mass, pressure increases. If you decrease the mass, pressure decreases. Mass of what? That sand on top of that piston that you remember from last session. या फिर वो ब्रिक जो उसके ऊपर था, डोंट वरी, फिर से वापस आएगा वो सैंड और वो ब्रिक, उसी हम लोग रिवर्सिबल और इरिवर्सिबल की चीजें पढ़ेंगे। एक क्विक समरी ऑफ लास्ट सेशन, ये सब प्रॉपर्टीज एक्सटेंसिव इंटेंसिव थी, ठीक है? इंटेंसिव इंडिपेंडेंट ऑफ साइज और मास ऑफ सिस्टम है, एक्सटेंसिव इज डिपेंडेंट, एंड ये सब एग्जांपल्स यहां पे थे। I ended the session with this idea कि there is something called heat and something called work, and अगर मैं adiabatic work को लूं so it will give me, this is important, not in NCERT but also very very important, okay? Adiabatic work is the same as heat. ये कहां से आया? इसका मतलब क्या है? देखो, if I write delta U as Q plus W, okay, what is adiabatic? Adiabatic मतलब Q equal to 0. If I put Q equal to 0, this becomes W adiabatic. Hence, work done adiabatically is going to be the same as change in internal energy. Similarly, you will say that delta U is Q plus W. Then you will say, you know what? W was what? Maybe I didn't do this part for you. I'll do this part for you this time, right? You say कि अच्छा change in volume अगर zero हो गया, okay, which means कि constant volume. अगर constant volume process है तो work zero हो जाता है, hence is equal to QE. This part I'll derive right now. ये हम लोग अभी करते हैं. Session 2 of thermodynamics starting right about now, ठीक है? Applications and work in isothermal free expansion of an ideal gas. Okay, let's start with that. Applications किस चीज की? We'll see. Let's see. If we have time, we'll probably do enthalpy as well. Okay. Internal energy एक extensive property है, मतलब it depends on amount of stuff. कितना सामान है, सामान नहीं, right? कितने सामान? How much mass is there? How many moles of, we're talking about gases, right? Remember, हम लोग किस चीज की बात कर रहे हैं? Till now, okay, till now, we are focusing on non-reactive gases. मैं आपको थोड़ा एक्स्ट्रा चीज बता रहा हूं, बट दैट्स व्हाट यू शुड नो व्हाट वी आर टॉकिंग अबाउट। अभी के लिए इसी चीज बात कर रहे हैं, एंड इट इज अ स्टेट फंक्शन। देयर आर 4 लॉज एंड यू विल बी वंडरिंग कि व्हाई आर वी स्टार्टिंग विद जीरो? इट्स बिकॉज़ द फर्स्ट, सेकंड एंड थर्ड लॉ, व्हाट इज दिस? ओके, फर्स्ट, सेकंड एंड थर्ड लॉ केम फर्स्ट, and you know, zeroth law was somewhere in between. So like, hold on, this is more fundamental, okay? Scientists figure out कि ये जो हम लोग बात कर रहे हैं, this is a lot more fundamental than the first law, okay? तो इसीलिए zeroth law बाद में ऐड किया गया। zeroth law is very straightforward, में same even obvious. What it says is कि अगर एक बॉडी दूसरे बॉडी से थर्मल इक्विलिब्रियम में है और कोई तीसरी बॉडी भी इससे थर्मल इक्विलिब्रियम में है, then first and the third body are in thermal equilibrium with each other. ज्यादा अंग्रेजी हो क्या? देखो, okay. The main idea is कि मुझे छूने में I may feel that the plastic pen is not that hot. I mean it's like it's okay. But जो metal laptop है, that's a little cold. It may feel that way, but they're the same temperature. They feel like कि अलग-अलग temperature है because कोई चीज heat को ज्यादा जल्दी transfer करता है, ठीक है? So everything around me is at the same temperature. That is thermal equilibrium. Whether I touch this or at that. So thermal equilibrium का मतलब है कि heat does not flow. When will the heat not flow? जब चीजों का temperature same हो. This is another way of looking at this. Okay. But if you want to talk about this specifically, zeroth law says कि अगर दो bodies thermal equilibrium में है with another body, then they are also in equilibrium with each other. This is again English and a little random, but this is what it looks like. ठीक है? There are 3 things. They are in touch with each other, right? So although A is not directly in contact with C, but because B is in contact with C and B is in contact with A, it will have the same temperature, okay, which may seem like very obvious, which means that TA equal to TC, which is pretty cool, which is insane, because in a way, without them ever knowing unke bagal mein kya hai, like A and B, they and C, they're still in the same temperature. I know this seems very absurd, but maybe if you do mechanical or chemical engineering, you will find all this to be relevant. ठीक है? We'll go over with this. I'm sure that there is no what the hell is going on, bro, on the chat. My good lord, bro, what's happening here? Are you guys seriously talking about Instagram? Get a life, man. पढ़ने आए हो, क्या कर रहे हो तुम लोग यहाँ पे? My God. Anyway, I'm back to teaching, trying to teach at least. Yeah, what that's actually named zeroth. Yeah, zeroth. I think zeroth. I think it should be zeroth. Like a e hona chahiye. I think there's an e that's missing. All right, bro. Anyone talks about Instagram is immediately getting banned. Like I have very low tolerance for BS over here. Like seriously, man, what is wrong with you guys? Yeah, thermostat is a good example. Okay, cool. Thank you. A thermometer, Archita. Thermometer also is a good example, right? Thermometer ko maine liya. This is the best example actually. We're going a little bit detail, but since you want to, let's talk about that. Anyone talks about crap other than thermodynamics is instantly getting kicked out. I don't care, right? We are here to study. Please take that seriously. Anyway, yeah. So thermometer, how is that an example? So, किसी ने thermostat बोला Ridhima. Ridhima, do you want to explain how do you think thermostat is an example of what you call it of zeroth law? And I'll try and explain how a thermometer is an example of zeroth law. How does thermometer work? Thermometer में एक metal bulb होता है. That metal bulb is in touch with my hand or whatever, right? I put it in the hand, it raises temperature, थोड़ा बहुत बढ़ता है. Or maybe I put it in the mouth, so like tongue से touch में रहता है, right? But what is actually measuring the temperature? It's not the metal over there. You learn this in physics, but किसी ने पूछा तो नहीं मैं बता रहा हूँ मैं. उसके बाद उस metal के अंदर, उस bulb के अंदर mercury है. That heat gets transferred to mercury, okay? And that mercury also reaches the same temperature as the tongue or whatever, you know, the cheek or jahan se bhi, wherever the thermometer is. So now, okay, the mercury is in thermal equilibrium with the metal, steel. And that steel is in thermal equilibrium with your skin. So in that way, your skin is in thermal equilibrium with the mercury and it shows the temperature. Okay, that's a simple example. Let's move on. I don't think we have to spend too much time on this. Yeah, exactly. Exactly. Awesome, awesome. You guys are brilliant. You guys are such awesome stuff. ठीक है, आगे बढ़ते हैं. First law, point of today's session. Energy. Sorry. Energy can neither be created nor destroyed. What does this mean? It can only be transformed from one form to another. Total energy of the system is always conserved. These are two ways of stating the same law. ठीक है. कौन सी energy? We are talking about internal energy. If you remember the last part of my session last time, उसमें क्या था? उसमें हम लोग बात कर रहे थे हीट और वर्क की. बट बिफोर वी डिड दैट आई सेड दैट व्हाट इज इंटरनल एनर्जी? सम ऑफ ऑल द डिफरेंट काइंड्स ऑफ एनर्जी, इलेक्ट्रिकल, ये वो 10 चीजें. टोटल एनर्जी इज कॉल्ड इंटरनल एनर्जी. ओके, तो यू विच इज इंटरनल एनर्जी चेंज करता है अगर आई मेक हीट पास थ्रू द बाउंड्री. कौन सी बाउंड्री? हमने सिस्टम डिफाइन किया, सराउंडिंग डिफाइन किया. तो या तो सराउंडिंग से सिस्टम में अंदर हीट आई या फिर सिस्टम से सराउंडिंग में बाहर हीट गई. देन you will change. Or work is done. Work is done. Work कैसे? Work मतलब क्या? What is work? I'll explain how we will treat work when you talk about gases. When gases expand or they contract, तब हम लोग work की बात करेंगे. Heat तो very easy to understand. Work we'll talk about on expansion and contraction of gas. We'll talk about that. तीसरा चीज है अगर matter enters. It makes sense if I put in more stuff, right? इसमें maybe I gave it this bottle example, right? This has some amount of air. If I drink some water, more air goes into it. So in a way, air की internal energy is increased because more matter enters the system. So this is a definition. Internal energy बढ़ती है. I told you just like a bank. Bank में पैसा डालो तो that's good, right? That's a plus side. So the plus and the negative sign I'm going to talk about right now has to do with inflow and outflow of energy, whatever energy may be. राइट वो थोड़ा एब्स्ट्रैक्ट एनर्जी क्या होता है ऑल ऑफ दैट. सो अगर हीट अब्सॉर्ब हो रहा है दैट मींस मनी इनटू द बैंक, दैट्स पॉजिटिव. और इफ वर्क इज बीइंग डन ऑन द सिस्टम, वर्क ऑन सिस्टम, तीन शब्द, वर्क ऑन सिस्टम, तीनों चीज जरूरी है तब पॉजिटिव है. हीट अब्सॉर्ब्ड सिस्टम, ओके. What is work? We'll talk about it. What is on system? We'll talk about these two things very soon. We'll talk about this. अगर I know I haven't explained it, we'll talk about this. हीट अब्सॉर्ब्ड इज फाइन, राइट? हीट अब्सॉर्ब मतलब कि हीट अंदर आ रही है. हीट एक्सपेल्ड मतलब कि हीट बाहर जा रही है. अंदर मतलब सराउंडिंग से सिस्टम के अंदर आ रही है. बाहर मतलब सिस्टम से सराउंडिंग में बाहर जा रही है. ठीक है, वी आर गुड अबाउट हीट, राइट? हीट इज फाइन. ये लॉ सिस्टम पे होता है और चेंज तब होगा जब उसमें इन या आउट होगा. ऑल राइट सर, स्लो. ओके पूजा, ठीक है. Is this okay? Anything you did not follow? And other people, Sachin and Kunal, if you're still around, you're most welcome to stick around. I timed you guys out for 5 minutes because I'm not going to tolerate anything of that sort जो तुम लोग बात कर रहे थे. But if you still want to learn, you're most welcome to continue this conversation here. My God, Nidhi, good to see you, good to see you, good to see you. Hello. Pooja, let me know if there's something you did not follow. So हम लोग एक चीज को डिफाइन करेंगे which is change. Change को हम लोग रिप्रेजेंट करेंगे by this symbol delta. I gave you an intro to this last time itself, but फिर से एक बार रिपीट करता हूँ. Capital delta, Greek word, and this is chota delta, the small delta. Okay, so D and triangle, yeah, bada change, chota change. Okay, ठीक है. So if I want to talk about work or change in work, actually I should not write change in work. I mean I should just write work. I have a thing with this, right? कभी कभी लोग लिख देते हैं DW, but it doesn't make sense to talk about DW because it's not a state function. Only state functions can you write D something. Like a change in something is possible when you have to talk about a state, but it's a path function. But ठीक है, some books write this, so this is why I'm writing this to be. It's a bit of detail, but ठीक है, छोड़ो. Let's just say work. Work is what? F dot dx. अब ये dot भी जरूरी है, but you will study its importance in physics. ठीक है? That this is a dot product and not a cross product. ये चीजें आप लोग वेक्टर्स में पढ़ेंगे. Don't worry about it right now. जब आप फिजिक्स में पढ़ेंगे वापस आप फिर से थर्मोडायनेमिक्स वहां पढ़ेंगे. You will study all this there as well. And यहाँ पे ये ऊपर जो एरो लिखी है, just trying to say that force has direction. You know this from the force तो थोड़ा बहुत न्यूटन लॉस पढ़ा होगा अभी तक 11th में भी, right? And the distance that the force is causing the object to move, that also has some direction. इसीलिए इसके ऊपर ये साइन लगा. मतलब both of these are vector quantities. Okay. So F is force and dx is displacement. Okay. अब मुद्दे की बात करते हैं अपने दायरे में, which is in chemistry. So again, non-reacting gases, ठीक है? कोई पिस्टन है और किसी कारण से, जो भी कारण हो, maybe I'm heating this whole thing, let's say, or whatever I'm doing, I'm causing this piston to expand. Okay, I'm causing the gas to expand. This is the piston getting pushed up. ठीक है? If the piston gets pushed up very little bit, so we say that this distance is dx. ठीक है? और dl, अगर पूरा लेंथ l है, छोटा लेंथ dl है, चेंज इन वॉल्यूम विल बी dl into a. कौन सा एरिया? एरिया ऑफ क्रॉस सेक्शन. ये एरिया, या पाई आर स्क्वायर, आई नो दिस लुक लाइक अ सर्कल, दिस एरिया, या क्रॉस सेक्शनल एरिया, that's the area. You don't have to worry about all that, but I'm just giving you the whole picture here. Okay, पढ़ लिया vectors? Oh, I don't have to explain all of that then. All right, good to hear. Multiply, divide. Okay, perfect, Ram. Good stuff, good stuff, good stuff. Science, I am teaching that. You can check out the NEET channel for this. I told you the content is the same. Archita and a few other folks I know, Joel, are from the NEET stuff, but they're still attending the JEE session because theory is the same. So good on them. You can also check those out. Science. गुफ्ती फिजिक्स भी तो मैं ही पढ़ा रहा हूँ. थर्मोडायनेमिक्स फिजिक्स में तो है, सेम ही है. फिजिक्स यहाँ पे पढ़ो वहां पढ़ो, सेम ही है. So what is the expression for, ठीक है, फोर्स के बाद गैस में थोड़ी ना करते हम लोग. गैस की बात हम लोग क्या करते हैं? गैस में वी टॉक अबाउट प्रेशर, वी टॉक अबाउट वॉल्यूम, वी टॉक अबाउट टेम्परेचर एंड आल्सो नंबर ऑफ मोल्स. सो वील ट्राई एंड get it back to these terms, yeah, because we want to talk about gases. Okay, ठीक है. And it's hint ऊपर लिखा है expression for PV work. Work क्या था? F dot dx. Okay, तो वहीं पे हम लोग लिखते हैं F is P into A, pressure into area. So physics आप जानते हैं ना, pressure is force by area लिखा हुआ है. Cool. P is external pressure, area of piston, force on piston. You'll note कि यहाँ पे external pressure लिखा है. इसका क्या मतलब हुआ? देखो, अगर if you put a weight on top of something, जैसे कि कुकर समझ लो, प्रेशर कुकर समझ लो. How does a pressure cooker work? There is that weight ना, थोड़ा बहुत देखा होगा, कुछ में तो देखा होगा. And जैसे ही सीटी बजती है, it goes up. So that gas is pushing against some weight. वो प्रेशर तो हवा का है ही, atmospheric pressure. We studied this in lower grades also. But there's also the weight of that, of that CT, the whistle. So what you're doing is you're pushing against that, right? So this is the external pressure we're talking about. That weight exerted by that whistle is a synonym for pressure on top of something that is being pushed against. I'll address this again जब हम लोग reactions की बात करेंगे, क्योंकि वहां पे external pressure almost always will be the atmospheric pressure. कैसे? देखो, if I say C plus O2 gives CO2, तो क्या बन रहा है? CO2 गैस बन रहा है. No, oxygen is getting consumed, but CO2 is getting formed. तो CO2 जो form हो रहा है, what is it what is it pushing against? It's pushing against the atmosphere. I know, थोड़ा abstract है. We'll talk about that later. But for now, external pressure का मतलब है जो भी उस पे apply हो रहा है. Sometimes it will be the atmospheric pressure itself. Okay, cool. So now, the work required to move piston a distance dl against an opposing force of magnitude F is this. अब ये व्हाट डज दिस मीन, ये क्या लिखा है, ओपोजिंग नेगेटिव कहां से आ गया, देखो लेट्स गो बैक टू दैट डायग्राम, राइट, सी look at this, the pressure is here, okay, let's say the weight of the piston itself, okay, this is the pressure, okay, and the expansion is happening against that pressure, तो इसीलिए यहां पे नेगेटिव साइन आ रहा है, okay. Another way to look at it is the force is m times g, m of what, piston, right, so force इस डायरेक्शन में है, डिस्टेंस डिस्प्लेसमेंट उल्टे डायरेक्शन में है, इसीलिए नेगेटिव साइन हम लोग लगा रहे हैं. इज दैट ओके, दिस इज इंपॉर्टेंट, ओके, एक्सटर्नल प्रेशर के अगेंस्ट देयर इज एक्सपेंशन, ओके, इज दिस ओके, प्लीज गिव मी अ क्विक थम्स अप इफ दिस इज ओके. साइंस ब्रो, वेयर एल्स? Aakash Byju's, man, NEET. Go to the bento links, you'll find all my 12th grade sessions. Is this okay? This is extremely important. The negative sign का कहां से, what is the goal behind the negative sign? Okay, the negative sign comes because जो external pressure है, force इस direction में है और उसके against expansion हो रहा है इस direction में, ठीक है, because my focus is the gas itself. Okay, cool. Or what is happening to the gas rather, ठीक है. So then the rest of it is just a little bit of math. I put work as this, so dW, I still want to say work is integral of this, actually work is integral of this minus P external times E times dl, and let's move this and make this integral P external times dV, okay. So work is going to be integral of minus P external times dV, that's it. P into V का क्या यूनिट होता है, later atmosphere, which is a unit of energy. I know states of matter आपके सिलेबस से हटा दिया गया है, but PV equal to nRT. This and this, both sides have the unit of energy, okay. तो लेटा एटमॉस्फेयर में कर सकते हो, या फिर you could also do it Pascal if you do SI unit, yeah, if you do लेटा एटमॉस्फेयर, or you can also do लेटा बार, ठीक है, with all those units work. 1 joule is कितना, ये इतना, ये सब चीजें लिखी हुई है. 1 लेटा एटमॉस्फेयर is this much, and also I could say is equal to 100. 1 second, I'm 1 liter bar, sorry, 1 liter bar is equal to 100 joule. There's also that, okay. If you, because आजकल NCERT में बार की बात होती है, right, when they say that one at the standard pressure is now 1 bar according to NCERT, but आजकल JEE NEET में still we use 1 liter atmosphere itself, you don't have to worry about that, okay. So again, getting back to sign convention of delta U, anything that increases internal energy, positive, anything that decreases internal energy, negative. वही था, heat added, awesome, work done, बढ़िया, वर्क एक्सपैंड हो रहा है, मतलब बाहर जा रहा है, that's not good, हीट बाहर जा रही है, that's not good, it's negative, okay. This is something, this is a summary of all of that, bro, okay, yeah, anyway, so is this good? Yeah, it's very distracting to see random comments. That's why if you see me, people who are not watching it live, you think what happened there. There was some dude being very random with people here, so I had to kick them out. Yeah, I have very low tolerance to that sort of stuff. But it's distracting, obviously. Is this all right? This is how the whole energy thing works, yeah? Both of this is in, which is positive. Both of this is out, matlab negative. Okay, cool. Now here's a quick question. A system absorbs 10 kilojoule of heat and does 4 kilojoule of work. The internal energy of system में क्या होता है? What do you think? Have I told you enough to be able to solve this question? That was very quick, Ram. Thank you for that answer. Have I told you enough to do this question? मैंने आपको इतना सिखाया है कि आप इसको कर सकते हैं from what I have taught you? Doing work का क्या मतलब है? Is it negative or is it positive? Absorbing का simple है. This is +10. What does this mean? What does this mean? I've highlighted things that are important. किसी भी टेस्ट में पहली चीज है कि फिगर आउट करना क्या जरूरी है. This is what is given. Delta U is Q plus W. Q in is positive, W out is negative. So if the system is doing work, in chemistry we say that is negative. ठीक है, physics में sign convention उल्टा है. I'll talk about that also later on. If needed, we can discuss that as well. Yeah? All right. Thank you. Archita, Gufti, Ram. Perfect. बहुत बढ़िया. बहुत बढ़िया. Shubhi, is this okay? Science, I hope you got your answer. और कोई है? Anybody else here? Okay, good. I think we've got this sorted. Well, you guys are brilliant. Okay, cool. So 10 minus 4 becomes 6, which is a simple idea. Increase by 6 closure. Excellent. What about this one? इसमें से कौन सा करेक्ट एक्सप्रेशन है फॉर द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स अंडर अडियाबैटिक कंडीशंस? अडियाबैटिक क्या होता है? आई हैव टोल्ड यू मल्टीपल टाइम्स, बट एक बार फिर से हम लोग बोल देते हैं. अडियाबैटिक बाउंड्री की बात होती है, राइट? ऐसी बाउंड्री जो हीट को सिस्टम से सराउंडिंग में न जाने दे या फिर सराउंडिंग से सिस्टम में न आने दे. दैट इज व्हाट अडियाबैटिक कंडीशंस मीन, राइट? अ बाउंड्री दैट इज मेड अडियाबैटिक सो दैट द सिस्टम कैन नॉट एक्सचेंज हीट विद द सराउंडिंग्स एंड वाइस वर्सा. डी ओके, इट्स ओके पूजा, पढ़ लो ये वाला. यू विल नेवर गेट कंफ्यूज इन लाइफ अगेन. मेरी बात सुन लो ध्यान से इस सेशन में. यू विल नेवर गेट कंफ्यूज अबाउट साइंस अगेन. या ओके, राम एंड अर्चिता सेइंग डी. इंटरेस्टिंग. ठीक है, अडियाबैटिक का मतलब क्या है? इट्स वेरी सिंपल. Q is equal to 0. That's all. No heat in, no heat out. मतलब Q is going to be 0. So delta U is Q plus W, and Q goes off. So delta U is W. That's it. As simple as that. Lovely, wonderful, good stuff. In a closed insulated container, a liquid is stirred with a paddle to increase the temperature. ये directly NCERT से. Which of the following is true? You are insulated container. Insulated का क्या मतलब है? कंडक्टर का क्या मतलब होता है? कंडक्टर मतलब लेट्स थिंग्स गो, वेदर इट इज हीट या फिर इलेक्ट्रिसिटी. हीट कंडक्टर मतलब कि हीट को जाने देता है थ्रू द मटेरियल. इलेक्ट्रिकल कंडक्टर मतलब इलेक्ट्रिसिटी को जाने देता है, इलेक्ट्रॉन्स को फ्लो करने देता है. इंसुलेटेड मतलब नहीं जाने देता है. हाय संजीव, पूजा थिंग्स डी एज वेल. डी पुराने वाले का. ओके संजीव, यू वांट ट्राई दिस वन आउट. एज यूजुअल डेल्टा यूज क्यू प्लस डब्ल्यू. एंड अगेन वही सेम चीज यहां भी हो रही है. आइसोलेटेड मतलब नो हीट ट्रांसफर. एग्जैक्टली सेम क्वेश्चन पूछने वाला है, जस्ट आस्किंग इन अ डिफरेंट वे. अडियाबैटिक वॉल मतलब सिस्टम सराउंडिंग a boundary. This is the same as boundary. Okay, please don't get scared when you see words like wall. That's another way to just say boundary. Okay, that's it. So delta U is equal to W, which may or may not be equal to 0. We don't know. But Q, नहीं, temperature बढ़ रहा है. Then if it's increased temperature, then definitely not. Delta U मतलब is positive. You will see that later on. अगले सेशन में you'll know how do I know confidently कि positive होगा. बताता हूँ. Heat, अगर टेम्परेचर बढ़ रहा है तो हीट उसकी बढ़ती है. We'll talk about that later. Not heat. Yeah, we'll talk about that later. Yeah, it should be A. Good job, Ram. अर्चिता, A इसलिए क्योंकि Q is equal to 0. Insulated मतलब Q equal to 0. अर्चिता and anybody else who feels this confusing, देखो ये बस इंग्लिश का गेम है, right? You need to be able to understand what the question is asking for. And unless you know what these words mean, it's going to be difficult, right? So thermo में there are a lot of questions in NCERT. I think there are some 40-50 questions. कितने थे? एक सेकंड, एक बार देखता हूं मैं quickly. Why is it blank? Blank. Let's see, एक मिनट. और चैप्टर भी काफी बड़ा है, तो really bro, it only has like 20 questions. Don't tell me. Awesome, it has 22 questions. खैर, exemplar में देखो, NCERT exemplar has some 60 questions. I remember it has a lot of questions, so please do those questions. You should be good. All right. NCERT ने धोखा दे दिया. All right. Let's figure out how to calculate work in different scenarios. Right? Different scenario मतलब अलग-अलग paths for different paths. Because work is a path function. Heat is also a path function. I proved that to you last session itself. Irreversible process मतलब path. Reversible also is a path. And free expansion is also a path. We'll see what these things mean. Irreversible पहले, सबसे प्रैक्टिकल प्रोसेस यही है, एंड ये मैं आपको लास्ट सेशन में भी दिखा चुका हूं. दिस इज वन प्रोसेस वन, दिस इज प्रोसेस टू. सो आई कैन नेम प्रोसेस वन एज से कंप्रेशन. यू आर विथ मी ऑन दिस, राइट? कंप्रेशन मतलब जब ईंट उसके ऊपर थी, एंड प्रोसेस टू इज एक्सपेंशन. एक्सपेंशन मतलब जब मैंने ईंट हटा दी या मैंने रिमूव द ब्रिक. दैट्स ओके, गिव मी अ क्विक थम्स अप, दैट्स ओके. ऑलराइट, 22 plus 14 इंटरनल. वाओ ब्रो, वेरी नाइस, वेरी नाइस. What was the doubt? Free expansion 0. Ram is on fire, bro. पर टेम्परेचर बढ़ रहा है तो Q नॉट इक्वल टू क्या? अरे अर्चिता, लवली क्वेश्चन. टेम्परेचर बढ़ रहा है, Q नॉट इक्वल. देखो, टेम्परेचर और हीट में बहुत फर्क है. इसलिए मैंने बोला था मेरी बात ध्यान से सुनो, और अगर बात सुनने में मुश्किल हो रही है तो एनसीईआरटी पढ़ो. एनसीईआरटी में बहुत क्लियरली लिखा है, और मैंने लास्ट सेशन में भी एंड में यही बोला था कि देखो, आई हैव एक वाटर का बकेट, मैं उसका पानी दो तरीके से का टेम्परेचर बढ़ा सकता हूं. एक तरीका, उसमें इलेक्ट्रिकल वर्क करें, उससे डायरेक्टली हीट हो जाती है. दूसरा, आई सिट एंड डू पैडल, पैडल करो तो उससे जो है टेम्परेचर बढ़ता है, उससे हीट नहीं बढ़ती है, टेम्परेचर बढ़ता है, इट गेट्स हॉटर बट देयर इज नो हीट फ्लो from the system and surrounding. Remember, when we say the word heat, Q, we are talking about exchange between the system and surrounding in thermodynamics. तो आपका जो नॉर्मल आइडिया है हीट का, गर्मी का, उसको दिमाग से निकाल दो. Q means heat that comes from surrounding to system or system to surrounding. And temperature is just a property you measure. So temperature बढ़ सकता है वर्क के कारण, as we just saw. ठीक है, okay? Yeah? Pooja and Archita, is that okay? That's important, extremely important. That's a lovely point, Ram. The kinetic energy that is given to molecules by stirring makes their relaxation time less, eventually increases collisions, that increases temperature. That's exactly what happens at the molecular level. But since जबरदस्ती आपके syllabus से हटा दिया गया, but I think you'll have it again. When you do kinetic theory of gases in physics, ये सब आएगा, एक कोलिजन होते हैं पार्टिकल्स के बीच में जिसकी वजह से एनर्जी बढ़ती है. थैंक यू फॉर दैट राम, यू आर ऑसम, थैंक यू फॉर बीइंग अ पार्ट ऑफ दिस ब्रिलियंट कम्युनिटी. सो हम लोग लेते हैं आइसोथर्मल इरिवर्सिबल प्रोसेस, मतलब हम लोग टेम्परेचर नहीं चेंज करेंगे. सो दिस इज पाथ, दिस इज अनदर पाथ, आइसोथर्मल इरिवर्सिबल, राइट? सो दीज आर कंडीशंस एक्चुअली. अगर हम लोग किसी चीज पे कंडीशन लगाएंगे, we immediately define a path. Okay, we'll see what I mean by that. So this is the standard definition of work: integral minus vi to vf p external dv. Why minus? Because we define expansion to be negative. ठीक है, this is why this is negative sign. हमने किया था ना, we did that, which means कि आप यहां पे अगर मैं एक्सपेंशन करूं, if vf greater than vi, then w is negative, and if vf less than vi, then w is positive. मतलब compression work is positive. That is the meaning of this. Okay, साइन जो बोल रहे थे ना, तो to write in one place compression, expansion, this is what you have to mug, nothing else. In chemistry, compression is positive, expansion is negative. हो गया खत्म पूरा साइन कन्वेंशन. इन फिजिक्स इट्स उल्टा, बिकॉज फिजिक्स में तुम्हारा फोकस है गैस, यहां पे मेरा सिस्टम है, मैं व्हाट आई एम डूइंग टू द गैस, राइट? फ्रॉम देयर इन फिजिक्स द फोकस इज टू एक्सट्रैक्ट वर्क फ्रॉम द गैस. ओ गैस से वी विल मेक एन इंजन रन, वी विल डू ऑल दैट. इन केमिस्ट्री आई डोंट केयर. In chemistry, I'm saying what is happening to the gas. System is the gas. So if something is compressing the gas, that is positive. If it's expanding the gas, that's negative. That is my sign convention in chemistry. Okay, cool. Please give me a thumbs up if you understood this. This is important. The sign convention वाले point of view से. Yes, पूजा, यही तो बोला. मैं तो खुद को गैस समझ के करती हूँ. Great, Archita. Whatever works for you. Jyot. Funny dude. Okay, cool. Abhinandan. Abhinandan, that is not for irreversible. That is for reversible. जो आप बोल रहे हो. We'll get to that. Irreversible process में, isothermal में, हम लोग बोल सकते हैं कि देखो, P external is constant. Irreversible का मतलब क्या होता है? मैंने बताया ना, हीट रख दी, सीधे नीचे आ गया, तो इट्स अ वन स्टेप प्रोसेस. Compression या expansion जो भी निकाल दी. P external is what? It's either the atmospheric pressure plus the mass of that heat, that brick, or if you remove it, then it is just the atmospheric pressure, right? So it is constant. So हम लोग integral sign से बाहर निकाल देते हैं. And then we integrate this. ये तो कुछ नहीं है. This integral dv is just vf minus vi. So work is simply this. Work is minus P external times delta v. खत्म. ठीक है? This is isothermal irreversible process. Okay, cool. Now let us see what happens if the final volume is greater than initial volume. मतलब expansion हो रहा है. That way you get it to be negative, right? If gas expands, work done is negative. आपको already बता चुका हूँ. We're just putting it down one place. अगर compression कर रहे हो, then work done is positive. That's it. That's it. Yeah. Mansi, why would my name be Adil? My name is Ashish. Mansi. Please, we are doing thermo. Let's stick to thermo. Santosh, you gotta focus on getting less negative marks, dude. And Santosh, you want to talk about general stuff? Anybody who wants to talk about general stuff, join my Discord servers, join the Telegram servers, links are in the description. Okay, cool. Let's move on. Let's move on. Hey, Khana, if you're gonna spam, you're gonna go out. पढ़ने के लिए आए हो तो यहाँ पे रहो. So, this is, and please pay attention, this is extremely important, okay? What is happening here is isothermal irreversible expansion. जो ईट थी मैं ईट को हटा रहा हूं. Okay. So this gas is expanding against the atmosphere. I'm going to write that. Against the atmosphere. Okay? And guys, be mature. This is like the worst thing to do for me to tell you, hey, theek karo. Who wants to do that online, man? This is a free space. Internet is supposed to be supportive and awesome. Please, 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 please. अपने whatever your parents have taught you, use that positively. ये सब क्या हरकतें कर रहे हो तुम लोग online? Anyway, so when you're expanding against atmospheric pressure, you can see that the total work can be given by this graph. What graph? P versus V graph. How? Because remember, it was P external times delta V. This is just like it's saying कि P ये हो गया इसका rectangle का एक part, yeah, the y-axis. This is the x-axis of rectangle. So P external times delta V is just this, is the area of this rectangle. So expansion में, this is the deal. Is this okay? Yeah, we good? Exactly, Ram, integration से area. That's very nice thing Ram has said. And we'll talk about that integration की कब जरूरत होगी. बस इस केस में हम लोग mainly बात करेंगे यहाँ पे कि we're mainly talking about it's just a rectangle, right? Integration ही हो रहा है. What Ram said is right. But we're not worried about integration at this point, right? Because it's irreversible. Okay, cool. What about compression? You will see कि compression में कुछ अलग चीज हो रही है. Compression is different. Although it looks like it's similar, it is very different. How is it different? The mass I have placed on this, that is the external pressure. And that is greater than atmospheric pressure. So in a way, let me use a different color so you see it on the same thing. If I plot, I can't plot. Ruko. If I plot atmospheric pressure over here, okay, and this is the craziest part. So you see that compression work is greater than expansion work, right? So compression में ज़्यादा effort लगता है, expansion से कम work निकलता है. In the same different things, yeah, that's the deficit. Deficit मतलब इतना कम चाहिए होता है when you have expansion. And if I increase the pressure, say यहाँ से यहाँ तक और भी ज़्यादा काम लगेगा, यहाँ से यहाँ तक और भी ज़्यादा काम लगेगा, यहाँ से यहाँ तक और भी काम लगेगा. You see that? So between two different volumes, I can have many different ways of doing work. Hence, work is a path function. Do you see that? Yeah? Pooja, Ram, Archita, this is extremely important. ठीक है? Irreversible work में compression and expansion के बीच में there is a difference in the work done. In expansion, work कम होता है. In compression, work ज़्यादा होता है. Okay, awesome. अगर दो स्टेप में हुआ तो क्या होगा? मैंने एक स्टेप का दिखाया आपको, ठीक है? दो स्टेप मतलब कि आधा ब्रिक पहले रखा फिर दूसरा ब्रिक रखा. सो आधा ब्रिक हो गया फर्स्ट वाला, फिर दूसरा ब्रिक हो गया दूसरा वाला. ओके, लेट्स सी हाउ दिस लुक्स लाइक. ओके, सो दिस इज ब्रिक वन, ब्रिक first half, let's say first half. This is this pressure and this is the full brick. You'll notice that our goal is always the final pressure because जो compression हो रहा है, in this case not expansion, compression हो रहा है, it's happening against some pressure. Okay, what is that pressure? It's the final pressure. So you can also say कि P final is the P external pressure. Okay, when you are doing numericals and all of that, कभी-कभी आपको P1, P2 दिया होगा, and you know it's an irreversible process. In that case, P2, the final pressure is the external pressure, क्योंकि उसके against ही expansion या compression हो रहा है. Okay, you'll notice that this work done is less than the work done in one shot. अगर एक shot में work होता, then it would be this much, right? Because एक shot में होता है, then it would be this full work. Let me take another thing to that. Yeah, if it was just one block, one brick, एक दार डालते, So less work done in 2 steps. Give me a quick thumbs up if you understand this. जैसे ही मैंने नंबर ऑफ स्टेप्स बढ़ाए, कंप्रेशन वर्क कम हो गया. मतलब my life is easier trying to compress that gas if I increase the number of steps. Similarly, you can also do this exercise by yourself to see कि अगर मैं इसको expand करूंगा in 2 steps again, right? Irreversible process expansion भी 2 स्टेप में होता है. मतलब कि पहले आधा ब्रिक रखा, फिर वो आधा ब्रिक भी हटा दिया. Then the work done increases. Then the work done increases. Okay? Yeah? This is the atmospheric pressure. And if it is a one-step process, then this would be the deficit. Yeah? इधर हम लोग वर्क एक्सट्रैक्ट कर रहे हैं. सो एक्सपेंशन वर्क ज्यादा एक्सट्रैक्ट कर सकते हैं इफ यू इंक्रीज द स्टेप्स. नाउ आई जस्ट गॉन फ्रॉम 1 to 2. ओके, एग्जैक्टली अर्चिता. बट कौन सा सबसे कम होगा? कंप्रेशन वर्क सबसे कम होगा रिवर्सिबल में. एक्सपेंशन वर्क सबसे ज्यादा होगा रिवर्सिबल में. यू सी दैट? ये अंग्रेजी बहुत जरूरी है. सबसे जरूरी चीज ये अंग्रेजी है. Sign convention does not matter. Compression work is minimum. Compression work is minimum when you have infinite steps. And expansion work is maximum when you have infinite steps. Archita has figured it out. Thank you for that. That was the next thing I was going to say. Okay, what is the work done during the expansion of a gas from volume of 4 decimeter cube to 6 decimeter cube until the blah 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 blah. Can you try this out? बहुत ज्यादा स्ट्रेट फॉरवर्ड सवाल दे दिया. ये सवाल नहीं करना चाहिए था. कर लो, बट ठीक है. आई थिंक आ चुका है. दिस इज अ पीवाईक्यू फ्रॉम नीट या जेई फ्रॉम 1 ईयर. आई एम नॉट किडिंग. दिस इज कॉमन एग्जाम. टेल यू व्हिच एग्जाम. होल्ड ऑन, बता सकता हूं वो किस में आया. दिस इज फ्रॉम नीट 2004. 2004 में नीट था क्या? यू आर कंफ्यूज इन दिस. हो जाएगा यार, आराम हो जाएगा, बिल्कुल हो जाएगा. Expansion of a gas 4 decimeter. What is a decimeter cube? लीटर ये होता है. decimeter cube सेम एज लीटर. ठीक है, ठीक है. 4 to 6 3 एटमॉस्फेयर. 3 into 6 हो गया, 6 हो गया ना. तो 6 into 100 600 हो गया. ओके, एक्सपेंशन और नेगेटिव हो गया. आई थिंक इज नेगेटिव 600 अप्रॉक्सिमेटली. इट बी वो है. दैट्स इट. सिंपल. दिमाग नहीं लगाना इसमें. व्हाट इज W? इट्स माइनस P टाइम्स B एक्सटर्नल टाइम्स डेल्टा V. एक्सटर्नल प्रेशर क्या है? 3 एटमॉस्फेयर. 6 minus 4 is 2. 2 into 6 is 6 liter atmosphere. After you get 6 liter atmosphere, you got to convert to joules. Okay, ये वाला मल्टीप्लाई करना है तो 606 हो जाएगा. If you do थोड़ा सा डिटेल में, 606 plus 1.8 तो 607.8, 607.8 approximately 608. ठीक है, this is answer to this one. Okay, वो कहानी थी irreversible की, and that naturally flows into reversible process that one of our students Archita has already figured out. राम ने तो बहुत, अभिनंदन ने बहुत शुरू में बता दिया था इसका क्या वैल्यू है. सो कंप्रेशन पहले देखते हैं. धीरे धीरे हम लोग ऐड करते रहते हैं सैंड, तो थोड़ा सा प्रेशर इज हायर देन द नीचे वाला प्रेशर, राइट? एक्सटर्नल प्रेशर स्लाइटली मोर देन द इंटरनल प्रेशर, व्हिच मींस कि दे आर ऑलवेज इन इक्विलिब्रियम. यू सी दिस सच अ ब्यूटीफुल कर्व दैट गेट्स रिट्रेस्ड. दिस इज अ हाइपरबोला. एंड इन फैक्ट अगर आपने थोड़ा बहुत पढ़ा है, दिस इज P इक्वल टू कांस्टेंट व्हिच इज Boyle's law. Yes, you know this, you know this, you know this. From 10th grade, you know this. अगर आपने सेजो मैटर किया, then also you know this. ठीक है? Cool? Any doubts here? ये ग्राफ बहुत cool है ना? I like it. Graph is being redrawn. See, we are increasing the pressure. Volume is decreasing. Yeah, initially pressure is low, volume is increased. Okay, great. And अगर expansion हो रहा है तो भाई get a vacuum cleaner, remove the sand, and that curve is retraced. See, the beautiful thing is the curve gets retraced exactly, right? So this is an ideal process that never happens. I know for you the graph is like this. मैं जैसे हाथ से draw कर रहा था, for you it's like this, but cool. For me it was this way. Anyway, so reversible process, ideal process ये कभी possible ही नहीं होते, but hey, we study them just for fun. Okay. Same expression, but now P depends on V. How? PV equal to nRT, right? They're gases, non-reacting gases. So we can't take it outside the integral. So we got to keep it in there, okay? Because what is this? P external hai kya? It's P gas plus dP. That's the actual formula, right? If you go on and expand this, dP into dV to almost zero होता है, इसको छोड़ दो, ठीक है? So then you get P into dV plus V into, sorry, yeah, actually, you just get this. इसको हम लोग हटा देते हैं. And P, as I told you, was nRT by V, substitute karo, and you get this beautiful integration, which is dV by V. dV by V ka integration is log, right? All of these are constant, you take them out. What is n? N is number of moles. Negative sign का ध्यान रखो, बाहर ही रखो. VF, VI, limits, जरूरी integration के keep them as it is. On integration, you get lnV, not log, you get ln. To convert that to log, you got to put a 2.303 वाला sign. If any of this is fast, then आपको maths revise करनी है. There's nothing new I'm doing here. ठीक है? The only thing I'm saying is कि you know what, boss, what I get here is ln VF minus ln VI. We'll use the log ka form and write it like this. Okay, so this negative nRT ln V2 by V1 or VF by VI. बस, yes, Ram, thank you. अभिनंदन बहुत पहले से आके बता के गए थे. कहाँ गए अभिनंदन? हाँ, अभिनंदन मुखर्जी. Work is 2.303 nRT log V2 by V1, but that is not correct. I didn't want to break the poor guy's heart. It was so nice. You need a negative sign here, my dost. It needs to be this. Abhinandan, aapke liye, if you're ever watching this later again. Negative sign. Don't forget the negative sign. If you forget the negative sign, then you got to write like this. You have to write 2.303 RT nRT ln, log VI by VF. That's fine. If without negative, then it's fine. Kyun? Log of A by B is negative log B by A. Same idea here. ठीक है? Cool. I can also write this in terms of pressure, right? Because P into V is constant, right? थोड़ा सा mathematical jugglery हम लोग करेंगे. V2 by V1 is P1 by P2. Why? Because PV equal to constant, right? So I can also write this as, wait, Boyle's law के कारण ना? I can also write this as this. VF by VI is PI by PF. We'll do this a lot. In thermo हम लोग थोड़ा बहुत maths करेंगे. देखो, अगर आप इस maths से आपको थोड़ा डर लगता है ना, थोड़ा maths practice करना पड़ेगा. ये वाला maths, just some basic integration, nothing complicated. Yes, Ram. हाँ, अर्चिता, थोड़ा सा मैथ्स में एफर्ट लगाना पड़ेगा, थोड़ा सा, बहुत थोड़ा सा. After that, thermo is so easy. And thermo is not something you just skip. हाँ, physics और chemistry दोनों में easy marks, bro. Please don't skip thermo, right? विनती आपसे, because you'll get a couple of marks. I mean, if for nothing else, just for marks. It's a lot like algebra actually. ये होता है, ये होता है, ये होता है. You just have to like click, click, click. Oh, डायरेक्ट थ्योरी सवाल. जस्ट टेस्टिंग जो मैंने आपको अभी पढ़ाया है. How do we do this? How do you do this? If you go from first principles, यहाँ पे आप पूछ रहा है कि रिवर्सिबल आइसोथर्मल एक्सपेंशन का फॉर्मूला क्या होगा. फर्स्ट प्रिंसिपल माइनस पी एक्सटर्नल टाइम्स dv minus integral p dv, that becomes minus nRT dv by v, limits of vi to vf. VI, VF, ठीक है, V2, V1. Let's say V1 is initial, V2 is final. Okay, cool. That becomes minus nRT ln V2 by V1. ये तो कहीं नहीं दिख रहा मुझे. अच्छा, तो ये वाला गलत हो गया, ये वाला गलत हो गया. Because, yeah, this should be negative sign here, this should be positive sign here. So, but I also know that P1, V1 equal to P2, V2, which means V2 by V1 becomes P1 by P2. So, I can substitute that in here and say P1 by P2. Okay, that's still not there, but I can make it a plus sign and then make it P2 by P1. And yay, it's B. Yes, thank you. Thank you, Ram and Pooja, for doing this quickly. मैं थोड़ा ड्रामा कर रहा था जितना, I was trying to slow it down as much as possible, but thank you. See, by the end of 2 years, you'll be able to do this within 5 seconds. ठीक है? 10 seconds tops, not more than that. Okay. Now, कभी-कभी सवाल में क्या होता है ना कि they don't tell you कि reversible है कि irreversible है. What do they don't tell you? Well, here's the thing. अगर P external की value constant है, then it's an irreversible process. It's as simple as that. एक छोटी चीज जो मैंने आपको लास्ट सेशन में बताई थी, but I will also teach you that through this question is this. Okay. इसमें से कौन से graphs represents an irreversible isothermal compression. तीन चीजें हो रही है, irreversible, isothermal, ये दोनों कंडीशंस हैं. कंप्रेशन मतलब Vf लेस देन Vi, है ना. Vi इनिशियल जो था कम हो रहा है, Vf greater than less than Vi. Okay, so Vf Ei. So with that Vf Vi thingy, I think we can eliminate some options. आप मुझे बताइए. Very nice, Ram, very nice. Vf Vi कॉन्सेप्ट से अगर Vf कम है Vi से, अच्छा एक एक करके करते हैं ना. जो चीज आसान लगती है उसको पहले करना है. आसान चीज क्या है? कंप्रेशन मतलब Vf is less than Vi. Vf is less than Vi, which means मैं सही लिख रहा हूँ गलत लिख रहा हूँ? हाँ, Vf is less than Vi. हाँ, Vf मतलब यहाँ पे होना चाहिए Vf, यहाँ पे होना चाहिए Vi, which is not the case here, not the case. So between C and D. अब ये क्या है? What on earth is this? Why are there two random points? Why is there no line joining them? See, the problem with irreversible processes is that you remember हमने एक rectangle draw किया था. So technically, this is the area under the graph, है ना? This is the work done. But I can't really plot it on a graph because I don't know. Like I have no way of knowing what path it took. Did it this path? Was it that path? I have no idea. You can't plot an irreversible process on the graph. That's the moral of this story. ठीक है? Irreversible process को आप लोग graph पे plot नहीं कर सकते हो because you don't know what happens in between. You know the final state, you know the initial state. You have no idea बीच में क्या हो रहा है. It's irreversible. That's the point, right? So hence C is the answer. I know ये थोड़ा abstract है, but खुद सोचने की कोशिश करो. अगर मैं एक स्टेप में कर रहा हूं और वो स्टेप बहुत जल्दी हो रहा है, how do I know बीच में कहां पे कौन सा वॉल्यूम कौन सा प्रेशर? How do I even measure that? I can't measure it. Hence you cannot plot it on a graph. ठीक है? इसीलिए ये वाला आंसर सी है. नहीं राम, एरिया फिक्स्ड है. राम, very good point. Ram saying area can be anything. I will say something different here. एरिया पक्का है. एरिया तो निकालना सिंपल है. एरिया तो ये हो गया. This is the work done. Ram, what do you think? I know, Pooja. That's what makes thermo a little bit difficult sometimes. Archita, I understand. ग्राफ वाले सवाल ट्रिकी हैं, but पढ़ो यार, हमारे साथ आराम से कर लोगे. और पढ़ना हो तो एबिंग पढ़ लो, अगर एडवांस की पढ़ाई के जूम डाल कर लो, but you'll be able to figure it out. Don't worry. Ram, area is against the external pressure. ठीक है? In this case, we are saying, remember, हमने बताया था, ये तो किया है ना राम, we just did this. So if we had compression, this is the compression का area. ठीक है? If we have expansion, this is expansion का area. Assuming, ऐसा ही assume कर रहा हूँ, this is atmospheric pressure, and this is PF, जिसके against compression हो रहा है. You see, because समझ रहे? पूजा प्रैक्टिस से होगा. ठीक है? I am teaching you new concepts using this itself. If we had enough time in life, then I would say कि पहले इसको पढ़ते हैं फिर वो करते हैं, but we are short circuiting things a little bit. और मैं कॉन्सेप्ट आपको सवाल के थ्रू ही पढ़ा रहा हूं. ठीक है? Ideally, they would teach you this separately, saying, hey, you know what, ग्राफ पे नहीं होता, ये होता है, वो होता है. If you want to read a good book on anything physical chemistry, this is awesome for JEE Main and NEET. If you want to do advanced, then this is a great book. This is the best book I've read for advanced school level की book. उससे ज्यादा पढ़ना तो Atkins भी है. But yeah, for main or NEET, if you want some extra help on physical chemistry, this is a beautiful book. Okay. If it's in multiple steps, Ram, वो भी मैं कर चुका हूं. Yeah? Ram, do you want to revisit that? I don't mind doing that, Ram. Ram, hold on. In fact, that's what I'm going to do next, but ठीक है, यहां पे देख लेते हैं. राम, ये देखो, ये 2 स्टेप वाला था ना. ये देखो मल्टीपल स्टेप्स में हो रहा था ना. एटकिंस है फॉर श्योर फॉर एडवांस्ड, बट दैट्स ओवरकिल ना. राम, ये देखो मल्टीपल स्टेप्स में हो रहा है ना. यहां पे क्या हो रहा है? यहां कंप्रेशन हो रहा है. कंप्रेशन वर्क इज गोइंग टू बी मोर, है ना, बिटवीन 1 स्टेप एंड 2 स्टेप्स. दैट्स व्हेन अर्चिता फिगर्ड कि मल्टीपल स्टेप्स में ही सबसे कम होगा. सो यू कैन मेजर, यू नो हाउ टू डू इट. सी, रिवर्सिबल हो रहा है, 2 स्टेप में हो रहा है, ये सब कर सकते हो. ठीक है? यू जस्ट नीड टू नो व्हाट द स्टेप्स आर. वेट, did we do all this? We did all this. Did we decide to skip free expansion? Where are we at? Did we not do? Oh, हम लोग ये सब कर चुके हैं. I was a little confused for a second. Done, 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 done. Okay, so what are the conclusion of first law of thermodynamics? अगर internal energy का change नहीं है, then heat is negative work. This is very simple. Yeah, heat absorbed by system is work done by the system. Right? अब ये by और on का क्या मतलब है? अगर on है तो positive है, by है तो negative है. On means compression and by means expansion. ठीक है? थोड़ी बहुत अंग्रेजी है, थोड़ा बहुत ये राइट ऑन फ्लैश कार्ड. ओके, एक्सपेंशन इज नेगेटिव एंड दैट मींस वर्क डन बाय द सिस्टम. गैस एक्सपैंड हो रही है और गैस कंप्रेस हो रही है, वर्क इज डन ऑन द सिस्टम व्हिच इज पॉजिटिव. ठीक है, सो दिस इज वैलिड एंड दिस इज वैलिड एज वेल अगर चेंज इन इंटरनल एनर्जी इज जीरो. दैट्स द फर्स्ट कंक्लूजन. सेकंड कंक्लूजन इज इफ वर्क डन इज जीरो then delta U is equal to Q. मतलब increase in internal energy is going to be equal to the heat absorbed by the system. Okay, all right, cool. And heat release by system. ठीक है, cool, awesome. Next conclusion, कि अगर heat zero हो गई, increase in energy is going to be increase in work done on the system, decreases work done by the system. Why? Because by is negative, on is positive. पूजा, एनसीईआरटी डूड. श्रीराम जी, क्या नहीं समझ में आया? आपका नाम बहुत बड़ा है तो सब जस्ट शॉर्ट टू श्रीराम जी. अगर आप अभी आ रहे हैं, मैं 1 घंटे से पढ़ा रहा हूं, इफ यू सेइंग सडनली बीच में नहीं समझ में आया तो पहले प्लीज बीच वाला पार्ट, पहले वाला पार्ट देख लीजिएगा. इफ यू बीन वॉचिंग फॉर द लास्ट आवर इज समथिंग यू डोंट अंडरस्टैंड, प्लीज टेल मी, आई विल ट्राई हेल्प यू आउट. लास्ट पॉइंट इज हियर यू गो, राइट? फॉर अ gaseous सिस्टम, non-reacting, etc., etc. Okay, हम लोग ऐसे लिख सकते हैं of W is going to be equal to minus P external times delta V. Right now हम लोग सिर्फ gaseous system की बात कर रहे हैं. आप यहाँ पे you could also say what work, electrical work, ये work, वो work. We are not talking about all that right now. ठीक है? P external times delta V is what the work is over here. Awesome. सब आदित्य, irreversible, reversible में differentiate कैसे करें? अगर बहुत ढेर सारे स्टेप्स हैं, इनफाइनाइट स्टेप्स है तो रिवर्सिबल हो गया, अगर काउंटेबल स्टेप्स हैं तो इरिवर्सिबल हो गया. और इरिवर्सिबल में, दैट्स अ गुड पॉइंट, लेट्स टॉक अबाउट इरिवर्सिबल एंड रिवर्सिबल लिटिल बिट मोर. विल स्किप द क्वेश्चंस फॉर नाउ, थोड़ी बहुत और थ्योरी कर लेते हैं. सी दिस राइट हियर, सिंस गुड इवनिंग आदित्य, हाउ यू डूइंग? एंड राम आल्सो हैड दिस डाउट, तो इसलिए मैं इसको थोड़ा और इस पे बात करना चाहता हूं. दिस इज कंप्रेशन. क्लियरली ये डायरेक्शन आपको दिखाता है कि इस डायरेक्शन में हम लोग जा रहे हैं, which means we are increasing pressure, decreasing volume, so compression हो रहा है. You can see that I have carried step 1, 2, 3, 4, 5, and at each step, this is P external 1, this is P external 2, this is P external 3, this is P external 4, and finally P final. तो मैंने कितने steps हुए? I have step 1, 2, 3, 4, and 5. So I have a 5-step compression process. ठीक है, इसमें पांचों स्टेप में करते 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 देखो, आई एम एबल टू कैलकुलेट वर्क इन ऑल दीज स्टेप्स. हाँ राम, आई कांट प्लॉट देम ऑन द ग्राफ बट आई कैन कैलकुलेट द वर्क. दिस इज द वर्क डन इन स्टेप 1 एंड ऑन द सेम ग्राफ आई कैन शो यू दैट बॉस एक्सपेंशन वर्क कम होता है. अगर आई डू द सेम थिंग इन 5 स्टेप्स ऑफ एक्सपेंशन, ठीक है, इट्स गोइंग टू गेट प्रीटी क्रेजी. एक्सपेंशन एक्सपेंशन एक्सपेंशन, इसको कैसे किया जाए? यहां से एक्सपैंड करते हैं यहां पे. तो द फर्स्ट थिंग इटसेल्फ इज दिस इज स्टेप 1, दिस इज स्टेप 2, दिस इज स्टेप 3, दिस इज गोइंग टू बी स्टेप 4. ठीक है, एंड दिस इज फाइनली एक्सपेंशन. ठीक है, सो हियर एक मिनट, एक यहां पे कुछ गड़बड़ी हुई है. P4, if this is the final thing, hold on, let me think about this one. So I have initial बीच वाले स्टेप, सेम बेसिकली सेम प्रेशर से. ठीक है, सो P5 से P4 एक्सपेंशन हुआ, देखो यहां पे कम हो गया. सो द डिफरेंस बिटवीन दिस एंड दिस इज दिस मच, राइट? कौन सा कलर यूज किया जाए? दिस इज द डिफरेंस ऑफ वर्क बिटवीन कंप्रेशन एंड expansion. In all the steps you can see that they kind of both coming towards the reversible line. Same चीज जो अर्चिता बोल रही थी. Yeah, Pooja, Ebbing, I told you Ebbing is a good book. Any doubts on this, Ram? How to calculate the work done in reversible process and all of that? And कोई पूछ रहा था नहीं समझ में आया, श्रीराम जी, irreversible reversible में फर्क क्या है? ये सब रिवर्सिबल वर्क है जो मैंने जो डार्क ब्लू कलर से लिखा है और हरे कलर से लिखा है, वो सब इरिवर्सिबल है। इरिवर्सिबल मतलब यू कैन काउंट नंबर ऑफ स्टेप्स। रिवर्सिबल क्या हो गया? मेक द स्टेप्स स्मॉलर एंड स्मॉलर एंड स्मॉलर एंड स्मॉलर, सो इनफाइनाइट स्टेप्स हो गए, देन यू गेट दिस लाइन, राइट? दिस लाइन shows reversible work. Okay, diamond, wow beta, I like it. I'm gonna screenshot that. Diamond clear, not even crystal. This guy Ram. All right bro, all right. Cool. Sriram ji, any doubts? Pooja, the book is ebbing. I've already told you. Anybody else asking anything you want me to address? I don't care about time. I have my day off tomorrow. I can take a little bit extra time and explain this. Plus, I really like thermo. It's like those things I like talking about. Other than Bhagwan ki baatein. Are all works reversible? Aditya, come on to Discord. Come on to Telegram. We'll chat more there. ठीक है? All right. So the next idea, the last part of today, yeah. अगर P एक्सटर्नल दे रखा होगा तब तो इरिवर्सिबल ही हुआ ना, आप समझ रहे हो श्रीराम जी? अगर एक्सटर्नल प्रेशर दिया हुआ है, इट हैज टू बी इरिवर्सिबल, राइट? But anyway, if you have specific questions and doubts, come to my Discord channel, come to my Telegram channel, share a working, and we'll help you out. They're awesome people. There's 746 people as of today, including 12 bots. As before I started the session, वहाँ पे बहुत लोग हैं जो, कुछ लोग IIT में, कुछ लोग टीचर्स हैं, बहुत बड़े-बड़े. They'll all help you out. जिसके पास टाइम है वो हेल्प करेंगे. So come to the Discord Telegram channel, ask as many doubts you want. I'm going to continue this. Last part, I'll take 5-10 minutes and explain this because it's जरूरी है, ठीक है? And we finish off enthalpy also. Spoiler alert. Since हम लोग सारे chemical reactions normally lab में करते हैं against atmospheric pressure, now we are switching gears. Reactions, chemical reactions, the colorful things. Okay, so we'll define another state functions जो इसके बारे में बात करेगा, ठीक है? You remember this? मैंने बताया था आपको कि अगर मैं एक कुकर जैसा चीज लूं, okay, and I heat it, then all the heat basically increases the delta U. If I go put heat inside system, because there's no chance for it to do work. Work क्या था? Expansion, compression, वो work था. अगर मैं volume constant रख रहा हूं तो work हो ही नहीं सकता है. How do I know this? W is equal to 0 because P external times delta V is 0, इसलिए 0 हो गया, ठीक है? So I can say that okay, that is fine, but let's talk about this thing. I want to find out heat at constant pressure, क्योंकि मेरे बगल में जो भी चीजें हो रही है, everything is happening under atmospheric pressure, especially lab वाले reactions, which is why we're defining another system. Okay, and what was this? P times delta V. This is just work. Okay, sweet. Now what is this delta V, delta U? U2 minus U1, U2 minus U1. Final minus initial. ठीक है, तो just substitute that over here. Now I can take this to the other side because this is the focus. QP is going to be equal to this. So I can write QP now to be equal to, oh, that's interesting. What is this? Okay, let's see. It's the sum of internal energy and the PV work of the final system minus the sum of internal energy and PV energy under some set of systems, right? That's what enthalpy is defined as. What is enthalpy? It is heat at constant pressure. This is heat at constant volume. अब ये क्या है भाई? Constant volume is a path. So heat at constant volume, although a path function, it happens to be equal to a state function. Similarly, heat at constant pressure, very much a path function, but is equal to a state function, which is enthalpy. What is enthalpy? This, literally this. Enthalpy is defined as U plus PV. Okay, H is the enthalpy term. इसलिए आप लोग electron gain enthalpy and all that पढ़ते थे, ठीक है? Not electron gain energy, which is the same thing for us, our discussion. बाकी सब चीजें same है, ठीक है? It's a state function and extensive property, just like its cousin delta U. Okay, let's do a little bit of math. QP क्या था? We derived this already. Not really derived, but ठीक है, we did this. So we'll see that both of these things are the same. How? Okay, let's expand this. QP is H2 minus H1, which is delta H. Okay, great. What does that mean? Delta H is the heat absorbed by the system at constant pressure. That's the definition. Technically, delta H is going to be delta U plus delta PV. But pressure or delta P is equal to 0, pressure is constant. राइट? दैट इज व्हाट QP मींस. हम लोग देख रहे हैं एटमॉस्फेरिक प्रेशर पे कौन से रिएक्शन हो रहा है, मतलब प्रेशर नहीं बदल रहा है सिर्फ उस केस में, ठीक है? एंड अगेन दीज आर रिएक्शंस हैपनिंग, नो मोर नॉन रिएक्टिंग गैसेस, लिक्विड है, सॉलिड है, सब चीजें इसमें, ठीक है? So I can write QP equal to H2 minus H1 is delta H, which now gives me this awesome equation, which is the definition over here. Now ये वाली चीज जेईई एडवांस में काफी साल पहले पूछी गई थी, ठीक है? Where you had to use this form of the equation, जो NCERT में नहीं है, but it's okay. But we took 30 more seconds to talk about this. Using this delta H wala business, we can define endothermic and exothermic processes, which is what we'll talk about अगले session में. You remember when I was defining system and surrounding, अगर मेरे सेशन आप ध्यान से सुन रहे हो, then this you'll really enjoy this, okay? मैंने बोला था कि सिस्टम तुम ऐसा डिफाइन करो कि it's only the reaction mixture, just C plus CO2 or just HCl molecules interacting with NaOH molecules, giving you NaCl and water and a lot of heat. How is that exothermic? That heat goes and heats up the surrounding, which is the water. Oh, so you measure that heat because of this system giving away heat. System can just the molecules. Similarly, there can be some other set of reactions that will absorb heat. कहां से? Surrounding से ही. कहां से? पानी से ही. इसलिए पानी ठंडा हो जाता है. What is something getting cold? If something loses heat, it gets cold. And that is how you explain that, oh, कुछ एंडोथर्मिक प्रोसेस ऐसे होते हैं जिनको आपको एनर्जी इनपुट फिजिकली आपको गर्मी नहीं देनी पड़ती. यू डोंट हैव टू हीट इट, बट दे टेक एनर्जी फ्रॉम द सराउंडिंग्स. If they take energy from surroundings lose energy, they get cold. That was fun, right? Anyway. We done? Okay. Yeah, dude, it's all in the bento links. I'm not sure if you guys are following. मैंने बोला था. There's a link over here. I'm done with today's session. I'm ready to take whatever questions you guys have. All was channel name. Pooja, सब कुछ link में है. Bento link है. Description में link है. There is a link that is pinned here, comment, click on that, you'll find whatever you guys need. Ram, U plus PV, right? I don't know, bro. Rishi, I don't care about term test, neither should you. Rishi, focus on JEE, NEET, do NCERT, do exemplar, do lab manual. बाकी जो भी बीच के steps हैं, it's like people running a race or playing basketball or doing anything else. Training में हजार चीजें करते हैं, but the actual game thing is अलग, right? So, no idea. Pooja is still asking a book for organic. Dude, I don't know about PUC, dude. I suggest Master Organic Chemistry to be a really good resource. Yeah, that's what I suggest. Again, links are there on the bento links. You go to my channel, go to my Discord server, type.chem, and you'll get everything there. If you want me to copy paste that stuff here, I can do that. It's going to be a lot, dude. But since you're asking, आप बहुत बार पूछ चुके हैं, I don't want you to go away from here empty-handed. I'll give you the links. There's a thing called ChemLiberText. I'm not gonna write it because I'm lazy. I'm just gonna type it all out. It's already typed out. I'm just gonna put a copy paster. Hold on. .chem. One second. It's gonna be a little long, right? So here you go. Since you asked, bro, can I paste that much? It's not letting me paste that much. Shoot. Minus 717 characters. Bro. Okay. First lecture is compulsory to watch. Aditya, nothing in life is compulsory, man. Organic chemistry. Okay. Here you go. Don't be lazy, man. थोड़ा बहुत खुद भी गूगल कर लिया करो. I'm going to do the unthinkable and share my screen now. Wait. Share my screen. Video capture by window capture 6. Let's go and put one more in here to say display capture. No, not display capture. Let's go window capture 5, and let's say instead of this, let's go Discord. Can you see my screen right now? You can't. How about now? No, you can't. How about now? Yes, you can. Okay, you can see my screen, right? Control plus 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 plus. थोड़ा बड़ा हो गया. So what to do for JEE Main or NEET in chemistry? NCERT के links, because you guys are lazy. Exemplar के, because again you guys are lazy. Lab manuals, again laziness. You can find all this online. Then some things that are nice. These are all again general things. जो न समझ में आए, chemlibertext.com, Master Organic Chemistry, and obviously Byju's and Topper sites. The reason I haven't given you the links of these is because They are the most popular sites online right now. Find them, you will find a solution to everything, every question, JEE NEET related. अगर आपको और theory पढ़नी है, Master Organic Chemistry, Chem Labortech, these are sites. Yeah, we only someone teach you to question. Hey, मैंने अपना नाम भी यहाँ पे नहीं लिखा है, right? Because I don't want to be biased. I'm being very serious. जिसका वीडियो देखना है, watch if they teach from first principles. Advanced में, yeah, Sumdal, Solomon, JEE, etc., etc. If you're wondering what this is a Discord server I run. It's a free server run for students, so they can just chat with each other and figure stuff out. Yeah. Okay, that's it from me. Thank you for sticking around. मिलते रहेंगे हम लोग. More questions कहाँ से करें? नूतन, अभी तो दिखाया आपको. हजारों सवाल हैं, जहां से करना है करिए. Go to the bento links, bro. I don't think you guys are even listening to what I'm saying, or you're just typing out stuff. Like, anyway, thank you for your time, everybody. Have an awesome evening. I'll see you again with more thermodynamic sessions on Thursday. मिलते रहेंगे. Bye. Good night. No, Pooja, absolutely not. I'm sorry. That was a bit too loud, but I've given you things that I think are the best. Everything else you do is up to you. ठीक है? Bye, guys. Good night. Bye. No, really, honestly, I honestly think that there are better resources out there. I've given you the links to those. Okay? Bye. Tata.